Welcome in our today's mathematics lesson, where we shall be looking at computation with negative fractions. Earlier on in our previous lessons, we have looked at decimals, we have looked at fractions, but we have also looked at computation of integers and computation of negative integers. Now, you realize that integers were easily shown on the number line. The number line was earlier on invented by John Wallis in the year 1616 to 1703. Now, when they invented a number line, John realized that you can simply represent negative integers as well as fractions so easily when using a number line. Just to illustrate what a number line is and remind you what it is, as you can see what I have here, it's a number line. It extends further to the right, endless, and to the left, endless. But now we are looking at fractions. So you can have, at every small scale, we have a fraction. So this is 0, a half, 1, that is 1 is equivalent to 2 halves. This is 3 over 2 or 1 and a half and so on. And the same we have on the left-hand side where we have the negative fraction. So a number line can be used to represent a fraction. When working with negative fractions, we are looking at the left-hand side of the number line, where in this particular case, we should be able to know that a positive integer, a positive fraction, we also have an equivalent of the negative fraction. So I want you to look at this. If you can have various fractions, like you can have a fraction like 1 over 2 and minus 1 over 2, this will mean like you are right here. As we said earlier, when you are subtracting, you move to the left. If we have to subtract a half, then it will mean from here we shall move towards the left. And the number of steps is a half a step. So you'll find that you will settle at 0. So you can still be able to work on fractions using the number line. In this topic, we are going to see how we can simply handle the computation of negative fractions. Now, to do this, we need to observe the rules. And here, we find that when operating fractions, just the way we handled the integers, that principle will still apply to the negative fractions. How we operate negative integers, the same way we shall also use the same principle to operate the negative fraction. 2, the arithmetic rules, here we find that those arithmetic rules that we observed in integers in our previous chapter, that is in chapter 1, will also apply in fractions. What are we trying to say here? Let us look at this. One rule, the first rule here, when subtracting When subtracting, in this case, a larger positive fraction from a smaller one. So we are saying that subtracting a larger positive fraction from a smaller one will result in a negative fraction. What are we trying to say here? Let us look at the following. If we are given a number like 1 over 5, and we want to subtract a larger positive fraction, for example, 2 over 3. Now, in normal ordinary case, we know that 1 over 5 is less than 2 over 3, which implies that what you are subtracting there is larger than the main fraction that is going to be used to subtract the other. So in this particular case, to approach that, in fractions, we cannot work when the denominators are not the same. So this implies that we need to get our denominators, and having gotten our denominators, then we work out. So the equivalent fraction of a fifth, given that we have the denominators 5 and 3, we look for the lowest common divisor. Lowest common divisor or lowest common multiple. In this particular case here, it is the product, which is 15. 15 divided by 5 is 3. 3 times 1 is 3. Minus 15 divided by 3 is 5. Times 2 is 10. So you can now see a fifth is equivalent to 3 over 15. 2 over 3 is equivalent to 10 over 15. Definitely here we are seeing 3 minus 10. It's a smaller fraction subtracting a larger fraction. And that's why we are saying in such a case it will result to a negative integer. Now, the denominator while subtracting or adding remains the same, so we maintain the denominator of 15. And then up here it is 3 minus 10, which is negative 7. Negative 7. So you'll notice that we have resulted to our answer being a negative fraction, hence completing the principle of saying while subtracting a larger positive fraction from a smaller one, it will result in a negative fraction. That is the case to consider, number 1. The second case we need to consider now we are seeing here that adding a negative fraction is equivalent to subtracting its opposite. What exactly do we mean here? Let us look at this. For example, let us look at a half plus. We want to add, and what we are going to add is a negative fraction as we have been told here. So I want us to take a half plus negative 1 over 3. That is what we have. We want to add a negative fraction. We want to add a negative fraction. So while adding a negative fraction, what happens? We have been told it is the same as subtracting its opposite. We need to know what do we mean when we talk about its opposite in this particular case. Now, when you talk of its opposite, just the way we saw in the number line, just to illustrate the number line first. If we have our number line here like this is 0, we can have here a positive of a half. It is the opposite of this one is here, which is negative a half. So each fraction has got its opposite. If we have 2 over 2, its opposite is here minus 2 over 2, and so on. So when they talk about it's like subtracting its opposite, then when they are trying to tell us here that we can rewrite what we have here as simply 1 over 2 subtract its opposite, and its opposite here is plus 1 over 3. That's what they are trying to tell us here. So this idea applies in both cases. When you're subtracting a negative fraction, is the same. When you're adding a negative fraction, is the same as subtracting its opposite. A negative 1 over 3, its opposite is positive 1 over 3. So you can proceed with our problem and see where we'll get to. So having done this, then we can simply conclude by saying that this can now be simplified, and we shall have 1 over 2 minus 1 over 3. Now we are ready. We have simply reduced this to a simple fraction where we are required to subtract, and we shall apply the ordinary way, where the 2, we have the denominators, they are not the same, so we have to find the LCD, that is the lowest common divisor, for 2 and 3, which is 6. So this one is 6. 6 divided by 2 is 3. 3 times 1 is 3. Minus 6 divided by 3 is 2. 2 times 1 is 2. So this one is 2 over 6. So these are equivalent fractions of this, respectively. So if that is the equivalent fraction, then 2 minus 3 minus 2 gives us 1. The denominator is 6. So we have been able to subtract this particular fraction from a half. Note that what we wanted to show here is that while adding a negative fraction, it is the same as subtracting its opposite, and that is what was shown in these two areas to arrive at this particular part. The third point to note. So here we are saying subtracting a negative fraction is equivalent to adding its opposite. What are we saying here? Let us look at an example here. So in this particular case, if we have a number like a half, we want to subtract a negative fraction. So a half subtract, and what we have to subtract is negative a third. Now you notice that we are taking a half, subtracting a negative fraction. So a half minus a third. So this is the situation that we have, and here you realize that we want to apply what we've been told here, that while subtracting a negative fraction, it is the same as simply adding its opposite. It's the same as adding its opposite. What are we trying to say here? Let's see. Now, the case here, we want to rewrite this just as per the statement. It's the same as adding its opposite. When we have add, The opposite of negative a third is positive a third. So we can write that and say, this is the same as a half adding its opposite, and the opposite here is a third positive. So you are saying it is equivalent to adding its opposite. So subtracting a negative fraction is equivalent to adding its opposite. That's what we have. And that one can be reduced to be now a half plus a third. And if you're working out that one, the LCM, or the lowest common divisor, is 6. This one will give us 3 plus, the LCM here is 6. This will give us 2, which gives us 5/6. I believe none of you has a problem in adding and subtracting fractions. That's why I'm moving ahead just to get the lowest common divisor, because we've done it several times in our previous lessons. But take note that when dealing with addition and subtraction of fractions, we must know how to get our lowest common divisor. But the principle here is that while subtracting a negative fraction, it is the same as adding its opposite. The next point to note. So here, the product or the quotient of two fractions of the same signs, where the same signs here is either positive, both of them being either positive, or both of them being negative, is a positive fraction. It's a positive fraction. Let us illustrate this. These are two positive fractions. If the positive fractions are being multiplied, this is a product, so we are multiplying. We are saying if the two of them are being multiplied and both of them are positive, the result is positive. So in this particular case, where we need to cancel, we cancel. But the principle of multiplying fraction, numerators are multiplied together, denominators are multiplied together. So 1 times 2 is 2, 3 times 5 is 15. So you will have 15, and the 15 is positive, not negative, because two signs that are alike gives us positive. Let us look at the product, but this time when the fractions are both negative. Now, here is a situation. You will be surprised that the results of the above fractions and the results of the product of the fractions next here is the same. From the rule here, whether both of them are positive or whether both of them are negative, the results must be the same. So in this particular case, we are saying we shall multiply the way we always handle it, 1 times 2. But remember, this is minus 1 multiplied by minus 2. So product of two negative numbers is positive. So this one will give us 2/15. Remember, it's minus and minus, negative and negative. The product of two negative fraction should be a positive. So you realize that this and this gives us just the same, and that one fulfills the rule that the product of two fractions of the same signs, either negative or positive, is a positive fraction. Let us now look at the quotient. Now we have 2 over 15 divided by a third. In division of fraction, we divide the numerators independently and the denominators independently. And we've said that if the signs for both the two are the same, the answer should be positive. So this is 2 divided by 1. You get 2 over 15 divided by 3, which is 5. So which implies that 2 over 15 divided by 1 over 3 will give us positive 2 over 5. Same would apply if we had negative 2 over 15, divide by negative 1 over 3. The same would apply if the case of this. The quotient of the two fractions which are negative must give us positive. We have negative 2 over 15 divided by negative a third. There are 2 negative signs, so the answer is expected to be positive. So we shall treat it like usual. Minus 2 divided by minus 1 is positive 2, and down here 15 by 3 gives us 5. So you'll find that our answer will be a positive fraction. That is to simply tell us that the principle of division, that is the quotient or product of negative numbers or positive numbers, will always give us positive fractions as its results. Now let us look at next point again that is very important when handling fractions. So looking here, the product or the quotient of two fractions of opposite signs. When you talk about positive or opposite signs, either one fraction is positive and another one is negative, or another one is negative, the other one is positive. So they are not alike, positive and negative. The product or the quotient of such valuation will give us a negative fractions. Let us see how that one applies. If we are looking at the product and then we have a number like a half multiplied by, now a half is positive, so we are going to have a negative fraction coming here in here. Let us take it like a quarter, negative a quarter. So before we even move on, the answer must be a fraction, correct? 2, from the principle or the rule that we've noted down here, the answer must be negative. So we are going to do the ordinary multiplication of fractions, but put in mind that the answer must remain a negative because it is the product of two fractions with opposite signs. So this will give us 1 times 1, which is 1, and 2 times 4, which is 8. But now, because this is positive and this is negative, it results to a negative answer. So our answer is negative 1 over 8. This simply applies in case it was the opposite. Like if we had negative 1 over 2 multiplied by positive 1 over 4. So this is positive and negative, and this is negative and positive. The result will still remain be a negative. So for the product of two fractions with opposite signs, the answer is always negative. How about the quotient or the division? Now, for the quotient, again, the same applies. If we have a number, for example, 1 over 8 divided by a negative of a half, we are dividing. An eighth is positive, a half is negative. So definitely the answer from the rule here must be negative. It must be a negative fraction because the signs are opposite. So when you divide this, it is 1 divided by 1, which gives us a 1, and then 8 divided by 2, which is a 4. The signs here are not the same, they are opposite signs, so the answer must be negative. If we had the other way around, for example, if we had negative 1 over 8 divided by positive a half. So this one was positive and negative, but the second one is negative and positive. It will still give us negative 1 over 4. So that's why we are saying that it is very important that we must be able to simply evaluate any problem touching on fractions with opposite signs. Now let us look at now practical examples and questions touching on the ideas that we have discussed above. Now, we shall go step by step as we look at each case. Evaluate 2 over 7 plus negative 5 over 7. And B, evaluate 2 over 3 minus negative 4 over 3. For the first case here, we are going to apply the rule of fractions. We are going to apply the rule of when we are adding a negative number, what does it tell us? So for the first case here, 2 over 7 plus negative 5 over 7, this case here, it means that we are adding a negative fraction. As we said earlier on, when adding a negative fraction is the same as subtracting the opposite, right? So what we are trying to say here is that the case here can be rewritten as 2 over 7 subtract the opposite. The opposite of 5 over 7 is positive 5 over 7. Now this is a natural fraction, it's positive, so the same can now be reduced to be 2 over 7 minus 5 over 7. So it has now been reduced. So we can simply go ahead and solve it. So when working out this, you'll notice that the denominator is the same. So we are only going to be concerned with the numerator because our denominator remains 7 And above it is 2, which is smaller fraction, minus 5. As we said earlier on when we started, we said when you take a smaller fraction, subtract a larger fraction, it results into a negative fraction. And that's why in this particular case, 2 minus 5 gives us negative 3. So our answer will be minus 3 over 7, which is a negative. So this case, it has proved the case of saying a smaller fraction subtract a larger fraction gives us a negative fraction. The second problem that we have a fraction subtracting another negative fraction. So when we take 2 over 3 minus 4 over 3. The rule said very clearly that when you are subtracting a negative fraction, it is the same as adding its opposite. What are we trying? If we are to rewrite using the same statement, we shall say 2 over 3, we are subtracting a negative fraction. It is the same as adding its opposite. That is adding its opposite. That's what it means. Adding its opposite. Opposite of negative 4 over 3 is positive 4 over 3. Take note of that. So this one can be reduced to be 2 over 3 plus 4 over 3. Looking at the denominators, they are all 3, so we maintain 3 here, and then 2 plus 4, which gives us 6. In fraction, we always say you must put your answer in the most simplest form. So where there are chances of cancelling, you cancel. And when you look at 6 and 3, there is a highest common factor between the two, which is 3. So you can simplify it by 3, 1, by 3, 2, and you find that you have your answer there as 2. We are not allowed to leave our answer in this form because there is a common factor that can simplify the two fractions, that is the numerator and the denominator. But what has led us to this particular point? It is the results of this part that leads us to the next point, which says that when you are subtracting a negative fraction, it's the same as adding its opposite. And that is what came up here, and it was easier now to reduce it to this form, and we have our answer. Still on evaluation, next question. Okay, we have 1 over 5 plus negative 1 over 4. And the second one we shall look at is minus 7 over 3 minus 3 and 2 over 3. Take note that this is a mixed numeral. So, starting with the C, it is taking us the principle of we are adding a negative number. We are adding a negative number. And the rule says if we have to add a negative number, it is the same as subtracting the opposite. What is the opposite of negative 1 over 4? So if that's the case, it is the same as saying 1 over 5, subtract the opposite of 1 over 4, which is a positive 1 over 4. So if this is the case, then it can be reduced and you simply have 1 over 5 subtract 1 over 4. Now that's where we've reached. Looking at the two denominators, they are not the same, which means using the lowest common divisor, we look for the equivalent fractions of both 1 over 5 and 1 over 4. The LCM, or the least common divisor, that is the LCD, of 5 and 4 is 20. We can use it as just the product. So if we take it as 20, 20 divided by 5 is 4. 4 times 1 is 4. Minus 20 divided by 4 is 5. 5 times 1 is simply 5. So we have 5 over 20 here. Now this is the similar case of subtracting a larger fraction, which implies that we shall have a negative fraction. So this one gives us 4 minus 5, which is negative 1 over 20. Negative 1 over 20. So that is what we get when we do the subtraction of the above fractions. Looking at the second one there, negative 7 over 3 is improper. 3 and 3 over 2 over 3 is mixed numeral. So what are we going to do here? We cannot handle the two when they are mixed like that. So we have to bring them to the same level. So negative 7 over 3 minus 3 and 3 over and 2 over 3. We have to change this one into improper fraction, and that means this one will be the same as minus 7 over 3 minus, if we change this one into improper, it is 3 times 3, which is 9, plus 2 gives us 11. So this is the same as minus 11 over 3. Now here we go. We are ready to move on. It is a negative number minus 11 over 3. The rule said very clearly that when you are subtracting a negative number, the two have got like signs. When you are subtracting a negative number, it's the same as adding its opposite. What are we trying to say here? This one means that minus 7 over 3, add the opposite here, which is plus 11 over 3. That is what this is trying to tell us. So if that is the case, this can be reduced and we have minus 7 over 3 plus 11 over 3. So we have reduced it to be like any simple improper fraction, which you can simply work on it. So minus 7 plus 11. Minus 7 plus 11 is the same as 11 minus 7. So we are expecting, this is smaller, this is larger, we are expecting a positive, which will give us 4 over 3. Now, 4 over 3 is already our answer. It is in improper form, but you can still go further and simplify it and say it is 1 and 1 over 3. And remember, it is positive. So take note that we are not able to handle it here because this is improper and this one is a mixed numeral. That's why we need to change it, all of them, to be improper, and then we solve it. The rule here we are observing was when subtracting another negative fraction. Yes. Let us now look at multiplying with negative fractions. Now here, evaluate 2 over 3 multiplied by negative 4 over 5. And B, we shall look at negative 6 over 5 multiplied by negative 3 over 4. Let us start by the first one. So as we saw earlier on, we say that when you are dealing with product of two numbers or two fractions which have different signs. That is, one is positive, another one is negative, or one is negative, another one is positive. Those are two opposite signs. Then the results must be negative. That applies for the first case. 2 over 3 multiplied by negative 4 over 5. You'll notice that the first fraction is positive. The second fraction is negative. So the results here must be negative. So that's, we already know that. So the principle of multiplying the numerators goes along. 2 times minus 4, which gives us minus 8, over 3 times 5, which is 15. So you find that when you work out this one, you'll get negative 8 over 15. That means that the two opposite sides, its product is always negative. For the second case here, we have minus 6 over 5 multiplied by negative 3 over 4. As we saw earlier on, we noticed that when you are getting the product of two negative fractions with the same signs, either both of them are positive or both of them are negative, then the answer should be a positive fraction. In this case here, both of the two fractions are negative. So if that is the case, then it will mean that we expect a positive answer, and the positive answer from the results of 3 times 6 times 3, that is 6 multiplied by 3 over 5 multiplied by 4. So where possible, we simplify. There's a common factor here. By 2 here is 2, by 2 here is 3. So you get 3 times 3 is 9, 5 times 2 is 10. This one is its simplest form. There were two negative signs, so the answer should be positive. So when we are multiplying two negative numbers, fractions, we must have the results as a positive. So I want us to look at dividing with the negative fractions. And the first question is minus 2 over 5 divided by, in bracket, negative 3 over 4. Second part is negative 1 and 1 over 3 divided by a whole number 3. So starting with the first part. When you look at the first part, you will notice that what we have is simply the product of, is simply the quotient of negative fractions. The rules say that when you are taking the quotient of negative fractions, then it means that the results will be positive because the two fractions have got the same or the like signs. So in this particular case, already we know what we are going to get. It's going to be a positive. Earlier on in our previous lesson, we say that when dividing a fraction is the same as multiplying by its inverse or its reciprocal. And that is very important to note. So that simply means that what we have here, we know the answer will be positive then. So what we have here, you'll find that this is the same as saying minus 2 over 5 multiplied by 4 over 3. Multiply by 4/3. This is the reciprocal of the other one. We have inverted what I'm calling, we have inverted the numerator and the denominator by swapping them. That is how we divide. So the sign changes from being a division to multiplication. So reaching here, the question was both negative fraction. The product is also both negative fraction, so we expect a positive answer. Simplify where possible is not there. So 2 times 4 is 8 and 5 times 3 is 15. Find that in that particular question, you'll get 8/15 and it's positive. You must be able to remember that there is a division here. Therefore, we must be able to get the reciprocal of the fraction because we are dividing. But the answer maintains the rule of the quotient of 2 negative fractions is always positive. For the second part here, we have a whole number which is minus 1 and 1/3 divided by 3. As you can see, it's a mixture of mixed numeral divided by a whole number. We cannot operate like that. We cannot work like that. But what we know is that one part is positive, is negative, another part is positive. So the answer is expected to be negative, simply because the signs are the opposite of each other, positive and negative. So this is a mixed fraction or a mixed numeral. We cannot work on this unless we change it into improper numeral, and that means that we shall have to change this one into improper. 3 times 1 plus 1, which gives us 4/3 divided by 3. In the division of fractions, we said earlier on in our previous class, when we are dividing with a whole number, we introduce a denominator of 1. And then we proceed by now saying we must get the reciprocal of the second part. So this one will give us minus 4/3 multiplied by 1/3. A third is simply the reciprocal of 3. Simplify where possible, but if it's not there, we move ahead. This one will give us minus 4/9. So on reaching here, we have been able to apply the knowledge of the division of a whole number. The reciprocal part has come in, and we have been able also to observe that quotient of 2 unlike sides should always be negative, and that's how we arrive at our answer of minus 4/9. Finally, let us look at now a whole mixed numeral divided by another whole mixed numeral. So we have got 2 cases. Both of them, they are whole mixed numerals. We need to divide. As we said, the 2 are fraction, at least what we know. The quotient of 2 negative fractions must be positive. We already know the answer will be positive. But we cannot get the quotient when they are in the form of mixed numerals. So we need to convert them into improper fractions. So the first part, it is equivalent to, this is 16/3. Take notice 3 times 5 plus 1. Divide by, this one is negative 20/9. That is 9 times 2, 18 plus 2, 20. So the 2 now are here. They are all negative. But then when you are dividing, it is the same as multiplying by its reciprocal. And the reciprocal of 20/9 is, we swap the numerator and the denominator. So this one will be the same as minus 16/3 multiplied by negative 9/20. We know the answer of 2 products of negative should be positive. So simplify where possible. 9 and 3, 3 is common, so by 3, 1 by 3 is 3. Between 16 and 20, the highest common divisor is 4. So by 4 here is 4, by 4 here is 5. So you remain with 4 multiplied by 3 over 1 multiplied by 5. That's what we have. This one will give us what? 4 times 3 is 12. And 1 times 5 gives us 5. Now, we settle at this, but because it is improper, we can now simplify it further. And what we have, we will find that 12 goes into 5 twice, so it is 2, remainder 2 over 5. So you notice that now it is easier for us to simply work out any mixed numeral as long as we are able to change it into the improper fraction. 2, we should also notice that the idea of getting the reciprocal of a fraction when we are dividing must always be known. We must always take the reciprocal. We don't just move ahead and work out. So that is how we work out while dividing negative fractions. That is it for now, but when we come back, we are going now to look further into more problems, statements that relate to fractions. Thank you.